Hi, I'm Brian Dipert, Editor-in-Chief of the Embedded Vision Alliance. I'm here today with Nik Gagvani from Cernium Corporation. Thanks for joining us today, Nik.
Thank you, Brian.
So I thought I'd begin, for those of us who, for those in the audience who may not be familiar with you or with the company, I thought we'd start out by asking you to give a brief rundown on your educational background and your professional background.
Sure, absolutely. I have been working in vision and prior to that 3D graphics for a while. I have a PhD which actually explored new boundaries that span both image processing, computer vision, and three-dimensional rendering. So it was a good mixture. I've worked at Cernium Labs, worked in the vision group for a while, and for the past 5 years I've been with Cernium. Cernium is a company that develops vision products. And we focus on video monitoring and surveillance. So historically, video monitoring has been passive in the sense that you could put up video cameras in convenience stores or in critical facilities and record all that video. Unfortunately, most of that video never gets looked at. And as the number of video cameras or security cameras grow, it becomes physically impossible to watch all of them in real time. So what Cernium did was we have used vision technology and boiled it down into embedded devices and on PC servers. And it's called, the market term for that is video analytics. So our products are video analytics enabled, and what they do is they watch the video so you don't have to. Mm-hmm. And as and when things of interest occur, that video gets forwarded to you or your attention is called to it. And that results in a huge force multiplier. We have installations where a single person monitors over 250 cameras more efficiently with our solutions than they were able to do before with multiple people. Watching surveillance video is a waste of time.
Right.
Correct.
Right.
Yeah, you're just sitting there, you're watching monitors and nothing is happening. And one of the cool things which kind of vindicates our whole idea of doing video analytics and embedding it in security cameras comes from the fact that when we often do demonstrations of our technology for potential customers, and we show them, hey, look, you can watch live video from any of your security cameras anywhere in the world at any time. When we go click, and they wait and say, okay, so when are you going to show me live video? I say, that is live. Nothing is happening. You can't tell it's live because there's nothing happening. There's nothing changing. And so the whole point being, when we actually do bring video to their attention after all the processing is done, that video has something interesting happening. Mm-hmm. and it's not ambiguous at all. So Arthur C. Clarke, the best technology is indistinguishable from magic.
Right, one of my favorite quotes. Can you talk about how, as the company has progressed through time, the product line has evolved, and specifically the feature set and the price point mm-hmm. transitions that have occurred?
Certainly. Cernium was, I should say, created, not founded. It was created as a organization within a larger organization back in 1996, and it was created to solve a specific problem, that of monitoring airport exit lanes. So the parent company, Ross & Berezini, does engineering consulting projects, and they did a lot of work for airports. And some of their airport customers approached them, and at the time, airport security or gate security was the responsibility of the airlines. They approached them and said, hey, could we not automate this? We have, the security guards standing there, or guards in some cases, and they're just directing passengers to go and get screened through the security checkpoints and not enter the gate area through what's called the exit lane, which is meant for people or passengers coming out. And so they got working on the problem and actually created the first exit lane breach detection system on a pretty powerful PC at the time, which happened to use a Pentium 2 class processor running at about 200 megahertz, mm-hmm. And did 2 channels of real-time video. So that was somewhat of a coup at the time to be able to do that, and then launched the first product. I should have brought the processors with me, but in fact recently we fast forwarded all the way down to where we are today, where we have embedded all of that into a single portable camera for consumers, which is about roughly the size of a cell phone, a little bigger than that. And our entire PCB board is about the size that that processor, just the processor was at the time. And it's not just advances in semiconductor technology or processor speeds that have made that possible. It's also advances in the state of the art as far as vision algorithms go.
The key differentiator in this or any other design is the software.
Correct.
Right?
Correct.
Talk a little bit more about that?
Certainly. So video analytics is about a decade-old term or an industry. And again, it emerged from computer vision researchers coming up with algorithms that basically do something that's called background subtraction or background modeling. And the idea being, if security video watching security video is a waste of time, the reason for that is nothing's happening. So let's call that nothing's happening the background, okay, and say this is ambient. There's nothing happening, it's the background. And anything that's changing is the foreground, and I care about the foreground. So only when you extract something meaningful in the foreground would you tell me about it. And there was a DART program called VSAM back in the mid-90s that kind of spawned a lot of research and actually brought it into the application domain, so to speak. And that's something that I believe still needs more work, more attention. And what I mean by that is the gap from an algorithm to a application down to a product, and that takes a while, and in a lot of cases may never happen. And part of the key to that, as you said, Brian, is the software. There's a comfort zone issue here. The researchers are comfortable working in the MATLAB OpenCV space, and if you look at the academic environment, where there's a great amount of work coming out, very excellent work, the incentive is to publish and move on to the next topic or finish your thesis and then move on to something else, which is very different than what incentivizes a product designer or a product company, which is to make the product work in the real world. And so I think the challenge is in making the two worlds meet and getting that pull all the way through into a product. And so clearly the software that you start with is not the same that you prototype. An embedded product is not the same that you actually go to market within a production environment.
And even when you have a product, there's no guarantee that that product is going to be embraced by consumers and accepted. I mean,
that is correct.
You and I have had some email conversations about, for the viewers, I've had several internet webcams running in my residence, my home office, for a number of years now. But I have an engineering degree. I've been in the tech industry for several decades, and it was even a bit of a challenge for me to get them set up. For the average consumer, for which getting it successfully set up is not an end in and of itself, and the camera is just a means to a different end. A lot of the solutions out there, even today, are not, from my standpoint, sufficiently user-friendly. I have not yet used your system, but from some of the reviews that I've seen and other people I've talked to that have, it certainly raises the bar substantially from a usability standpoint.
Well,
can you talk a bit more about that?
Sure, certainly. And Brian, you're right. It is not. When I graduated from grad school, I used to think, gee, this is the coolest algorithm. It's going to change the world. Let me go just provide it to people, and they're just going to figure out how to use it. But I was wrong. And my supervisor at the time told me, he taught me an important lesson. He said, no, you have to look at it from the user's perspective, right? Else, why don't you sell them ice cream? It'll sell more than this. I did not believe that at the time. I do now. So the key there is you got to really put yourself in the user's shoes. You got to solve a problem, and you got to solve it effectively and better than what's out there, better than the alternative. We all are, real excited about Apple's products. That they've done a marvelous job of basically making the user interface transparent to the extent that you don't notice that it exists, right? And we have attempted to do a little bit of that with the products that we have launched, the Archerfish line that we launched in the consumer space. And in the consumer space, it is not about the analytics or the technology. That might be the catchphrase that gets people's attention. It may allow them to make the buy decision, but it's not what excites them about the product and makes them want to refer it to their friends and family and everyone they know, and jump up on top of the roof and say, hey, look at this cool thing, this great thing, it's really helped me. And part of the challenge we faced was, certainly there are homebrew solutions people have put together. In fact, if you look at some of our reviews on Amazon, we were a little surprised. We thought we had created a product that was very easy to use, plug and play. Yet there were folks who like to tinker and said, oh, I can do better with my PC and a webcam and this free software I can download from here and cobble it all together, missing entirely the point that you had to have a PC. If you add the cost of a dedicated PC and the webcam and all the effort that you had to put in, you can get it running once. Great. To keep it running when you're actually away from home, what if that PC reboots? What if it gets a software update, which happens all the time? You just lost your surveillance capability. So we had to make it real simple and we decided that the customer has to be able to literally plug it in and go to the web and set it up. One of our models was, I can ship it to my mom, let's say, and say, hey, just plug it in, and I'll set it up for you from where I am. Right? And the customer need not know anything about IP addresses, or what IP means for that matter, or about what video analytics or embedded vision mean. And that's a huge leap in the maturation of the technology, because again, as recent as maybe 6 or 7 years ago, when I was doing this, in a prior life, we would in fact kid ourselves about saying, hey, listen, we just sold a system, and which engineer are we going to send with it, right? Right. Because an engineer will go with every system just to keep it up and running.
People like you and I, the techies, were in a sense sort of the worst people to define products, far from review them. I, as a reviewer, I naturally step over or go around stumbles without even realizing that I've done so, that most people would trip over. Did you do a lot of case study testing on beta versions of the hardware and software and refine those? I assume some of that at least went on.
Yeah, we did that before we, in fact, started working on the hardware, which in hindsight made a lot of sense, because you don't want to be on the product development path and make platform decisions and start marching in that direction, and then learn sort of late in the game, oh, wait a minute, I really should have changed that feature or had a different feature. So we did that up front. We did a good amount of market research. We targeted a demographic that was affluent, higher income range with a broadband connection, one or more mobile handsets. In fact, when we started conceiving this, the iPhone had just launched. So smartphones, if they were feature phones, they were not smartphones. But certainly, the trend was that phones would have video capability and a lot of video playback capabilities. So we targeted that demographic, and we actually engaged market research firms and did focus groups with the target demographics, both in person, and we ran interviews, over the phone and through the web. Collected a lot of data, and that included both residential customers and business owners. So what that told us was that there is a market for this, and one of the interesting things was most of the folks that we had targeted did have a security system with contracted security that they were being provided by one of the security companies, and they were paying a good bit of money every month. Let's say on average about $40 a month. Plus they were paying for broadband, which is another $40 to $60 a month, and yet they saw a place for this product. And the feedback we got was, hey, can I use it for things other than security? Which was interesting, because it's video. So I would like to know when the kids get home. I would like to know when the package gets delivered. I mean, so the horizons expand automatically at that point beyond the initial application that you had intended it for.
Well, the other common application I see for systems like yours is baby monitors.
Definitely.
And that makes a whole lot of sense as well.
Correct.
We've sort of talked so far about the products, as I understand it, at both ends of the company's spectrum, right? The airport security stuff that you started with, and the most recent product. And by the way, you said you targeted affluent potential customers, and I want to make sure that I have the price point right, so I'm going to ask you to say it versus saying it myself, but it's still quite an affordable solution. Right?
Absolutely, yes. So, we targeted a price point, a street price of about $300 for the camera, which was a fraction of what similar cameras in the security industry cost, which are north of $1,000 still. And it was well within range of other IP cameras that are available out there.
Right. So we've got the products on both ends of the spectrum. I know there are other products in the company's product line as well. Can you mention those as well, please?
Sure, absolutely. So one of the things, so there's a product we have in the middle, we call it Check Video. And the Check Video product is actually aimed at security integrators and dealers. One of the lessons we learned trying to market directly to consumers with a consumer electronics product, either sitting on store shelves or going through e-tailers, was that the average customer does not wake up in the morning and say, let me go out and buy a security camera. And, oh, by the way, I'm going to walk to Best Buy and do that. We would love for them to do that. I'm sure the retailers would love for them to do that. But that's not the case right now. If they have a security issue, which is when they might think of a video camera, they're going to call this a security company. Right. So Check Video is a product that's sold through security dealers and security companies. And it fills that middle niche of what we call light commercial applications. Your convenience stores, gas stations, the majority of places, or medium businesses, professional offices and whatnot. The idea being that most of these facilities, locations, do have video cameras installed, or will install video cameras. In most cases, these video cameras are being recorded passively to a DVR that's sitting in a closet in the back. And when an incident actually occurs, an attempt is made, mostly unsuccessfully, to find the video. And we've all seen the really grainy video clips, on TV shows, where it's almost impossible to identify the suspect. The suspect that was wearing a red jacket. No, wait a minute, that's brown. Wait a minute, I can't tell if it's a jacket or a sweater. So it's been pretty hard. In most cases, people buy it as an insurance policy. Buy the cheapest you can get away with, not realizing that they're really not buying something that's going to work for them. So that's the demographic we have, or that's the market segment we are targeting with the Check Video product. And the interesting part is, if you look at, and it's an add-on or a complement to existing alarm systems. So I can call my alarm company and say, okay, put in an alarm system for me. And the alarm system today is what I call a blind alarm system. So it's not passive anymore, right? Video recording is passive. The alarm system is proactive in the sense that when the alarm goes off, let's say someone opens your front door, you have armed your system before you left home, it's going to send a signal to a monitoring center. And an operator is going to look it up and try to contact you. And if you either say, hey, I am not at home right now, or you do not answer, they dispatch law enforcement. Trouble is, the unfortunate statistic is that a vast majority, and I mean 95+% of these alarms are false. So law enforcement gets dispatched, they show up, find nothing, and that's an expense. That's a cost to the local authorities, to the municipalities. And more and more frequently, we're seeing jurisdictions either impose fines for false alarms, or in some cases, after a few number of false alarms, just simply stop responding.
Right.
And that's a problem. So
the boy who cried wolf.
Exactly.
Yeah.
You cried wolf too many times.
Right.
You're right. And so one of the things Check Video does is it makes this blind system not blind. Right. It provides what's called video verification. And video verification is huge because now, in addition to the message, going to the operator saying, front door on 12 Main Street is open, they can now look at the front door of 12 Main Street. And we actually go a little further with embedded vision, because what we do is we identify the right segment of video that they need to look at. And then that is a crucial element of the whole equation, because with the absence of embedded vision, the operator can look at the camera, but it's been several seconds to a couple of minutes since that door actually got open. So they actually had to queue up a DVR, try to hunt around. In the case of Check Video pushes and delivers a crisp 10-second video clip with the person opening the door right in there.
Right.
So their job is pretty easy, and they love it.
Thought maybe we'd dive a little bit more technical
Sure.
for a few minutes. One of the initial foils in your presentation, as I recall, is a 4-quadrant foil that talk, still and video images, and then online and offline, real-time and offline processing. That latter transition between real-time and offline is one I'd like to explore a little bit more. Can you talk about why you had that foil in there and how that affects the way that a system might be designed?
Sure, and I think there's exciting things in all 4 quadrants. So again, just to repeat what Brian said, I mean, if you look at embedded or just vision applications in general, right, you can have them either real-time or you can have them non-real-time, and you can do vision with still images or with continuous image sequences or video, and there are significant differences based on which quadrant you are in. And the one that has been around for a while is the offline, non-real-time image processing, right? And a lot of computer vision focused historically on that. It's just over the past, I would say, 10 to 15 years that trend has changed towards either video or real-time processing. And with the real-time aspects, the embedded becomes more and more relevant because now you can sort of act upon things as they are happening. And the real excitement is sort of in what I call the top right quadrant, which is the real-time vision processing with video. So you're dealing with a lot of data and you're processing in real time. A great example being a collision avoidance system, either for a robot or for an automobile. And you had to get it right, and you had to get it right in a very brief time span and actually act upon it.
Right.
And God forbid you made a mistake and take the wrong action. So that tends to be the most challenging application. Although I don't want to discount the fact that even the non-real-time aspects or things that are done with images are getting a lot more sophisticated. There are great examples in photogrammetry, remote sensing. I mean, we're all used to now looking at satellite views and Google Earth and whatnot. And a lot of that would not have been possible without sort of the offline image-based vision that has evolved and matured over the years. And I think there are several applications that are emerging and will be coming to maturity over the next several years in the offline processing of video. The beauty of offline processing is that you can spend your time on it, but at the same time you can process vast amounts of data and correlate across video streams, which is a lot more challenging if you're doing it in an embedded real-time sense.
Okay.
An example would be, hey, I would like to find, this is sort of still an open problem, even back in the securities industry, is, hey, I would like to find, click on the person as they're walking, let's say, through an airport and say, find me all video clips in the last 10 days that had that person. That's pretty darn challenging, right? And a consumer application of that would be, here's all the video I shot. It's so easy to shoot video these days. I can never find that exact moment. I want to see my kid, hitting that home run. Can I find that video instantly? Not if I have not indexed it prior.
Right.
And I'm just going away happily, clicking and shooting. Wouldn't it be great for embedded vision to do that for me?
So you made a few minutes ago an explicit correlation, I think, between real-time video processing and embedded vision. And I think I even heard you say you correlated it to the transition from computer vision to embedded vision. I think I know what you meant by that, but I'm not 100% sure. Maybe the audience isn't either. Can you elaborate a little bit more on what it is that...
Sure. If you look at the video processing chain, right? I mean, it all starts with the optics and the imager. That's where the photons get converted to electrical impulses and image, the image formation process occurs. And the closer you get to that process, the latency is shorter, right? But then if you extend that pipeline all the way down, you can do some low-level image processing to enhance the image, make it look better. You can do compression. You can transmit it. You can again decompress it, and now you can lay it out in a data structure or in a database, and then go back and process it on a rack of servers, if you will. Right? That would be the offline model. And so if I look at my home video, much of it is offline. Once I've captured the video, it goes in my video archive and it sits there till I decide to do something with it or edit it. The embedded processing, but let's say I would like to make a real-time decision. I'd like to make a real-time decision is only shoot video when my kid is smiling, for instance, right? That decision cannot be made all the way downstream in the chain. You got to make it while you're capturing the imagery so that you can start recording it and transmitting it.
Right.
And so that's kind of what I meant by the real-time, or trying to correlate the real-time aspect with the embedded aspect, in which case now I actually had to do the processing pretty close to the point of capture or within the device that's doing the capture itself. And hence, you know, it has to be embedded in that device.
I guess it's something that I hadn't explicitly thought about until this point when you brought it up. A lot of the times the transition from computer vision to embedded vision is driven by, you know, increased reliability. You want to get away from a PC operating system based approach. You certainly want to shrink the size, the weight, the power consumption, oftentimes the cost of the system, but that it inherently enables real-time processing that wouldn't be possible in the traditional architecture is interesting.
Exactly. I mean, robotic navigation is a great example. I mean, the robot's got to make a decision which way to move based on processing, and you probably want to process it right there and on board rather than have the robot stop and then. Imagine you make a Mars rover, right? I mean, the round-trip time to transmit the video and the command back is minutes.
Right.
I mean, that rover is not getting very far in a day if you did that.
Another question. You talked some, and we've talked already before, about the localized processing versus cloud-based processing versus a hybrid model that incorporates elements of both. Can you speak a bit about that?
Certainly. So that's something, I talked about the check video product. And I think the real strength is going to come from a combination of the two applied appropriately, because there are always going to be limitations in the embedded space, whether they are computational, complexity, how many cycles do you get? Power is a big one, and just plain memory. I mean, if I'm really trying to correlate something 10 minutes ago, it's kind of hard to cache that amount of video on an embedded device.
Right.
But you can complement that with cloud-based processing, which is offline, processing, and I can go correlate it across time or across views and cameras, and I can probably derive some novel intelligence, and there are a lot of applications for that. We actually do use that pretty effectively with our check video product, where the baseline processing happens on the device itself and then gets uploaded to the cloud. And now we can do more interesting, what we call business intelligence applications. A good example of that is, I'll give you the same example as before. Let's say I'm a small business owner. I have a convenience store. And I would like to obviously use the check video devices for security and video alarm verification. That's after hours. But I got the video in the daytime. Maybe I can put it to some good use. Now we happen to have a really good person detection algorithm embedded onto the device itself. So every time there's a person, it can easily create a video clip, but during the daytime, these are customers. I don't want to alert a monitoring center for that. Well, guess what? We take all those video clips, we store it in the cloud, and now we can analyze customer patterns. It's a very simple example: how many customers entered the store, how many actually ended up at the cash register.
There are a number of embedded vision processing options available, and many of the Embedded Vision Alliance members represent some of those options. And you talk about that in your presentation as well, whether it be a conventional CPU, a DSP chip, a GPU, an FPGA, and other options exist, and combinations of those various things. Do you have any thoughts on that you'd like to share?
Certainly. I mean, the interesting part is I do believe even today that most vision algorithm development still starts on the PC. So it's the x86 architecture using MATLAB or some high-level programming language. However, that is not the best platform today for an embedded application due to power and memory and size constraints. And if you're looking at specialized processing blocks, if you're doing vision, you're talking digital video. You have to digitize it. If you're digitizing it, you probably want to compress it. So you're talking about a codec, so a hardware codec is preferable. And then having accelerated blocks, you've got a few options there. One, you can write it on the general purpose processor. It's going to be pretty slow. Most of them now do have some manner of SIMD processing, so that does help to an extent. DSPs go a step further. With FPGAs, you can write some pretty custom logic and accelerate algorithms or certain choke points, if you will, pretty well. I think it all comes down to a trade-off between cost, complexity, time to market that you're trying to target. I mean, if you're looking at high-end, either medical or defense applications, an FPGA with just the right techniques is probably fair game. If you look back at just mass market consumer, pretty much everything is overkill because, or you are pricing yourself out even today till you can kind of boil it down to an ASIC, right? And then there's the in between where DSPs I think have a pretty big role to play.
Okay. So you've been in the space for a while and you've seen technology evolution and benefited from it clearly in a lot of respects in the designs that you've done. A two-part question. Looking forward, how do you think embedded vision technology in particular is going to evolve? And for the people watching this who are in the embedded vision industry space as potential suppliers to somebody like yourself, how could they evolve their products and their development tools and all of these things to make your job easier and to further accelerate the embedded vision trend?
Correct. Good questions. I'll answer the first one. I can put on my put on my thinking hat and try and project what the applications are going to be. I think they're going to be really, really compelling and wonderful applications over the next decade or so. I think we have turned the corner. We have sort of crossed that bridge where developing an embedded vision product, or a vision product for that matter, is actually within the realm of possibility for a couple of guys in a garage, right? Which was not the case, 5-10 years ago. And that's the difference. I mean, we are seeing this huge explosion, if I can borrow an analogy from the Web 2.0 space, a huge explosion in the amount of companies and startups and people just trying to come up with interesting ideas and algorithms and just creating apps for that matter. Because the bar for developing that and the frameworks are so evolved, it is actually possible to do that. Now, if you look at vision technology, it's getting there. It's not quite there, but it's getting there. So with some knowledge of vision and some pretty decent programming skills and possibly hardware skills if you're going to go embedded, you can put together an advanced prototype or in some cases a product. And it doesn't take a whole lot of resources because those building blocks are there. And there are certain standard building blocks. I mean, starting from development kits, that are running embedded Linux, which is now a familiar operating system, to actually accelerated vision processing blocks embedded in the processor that are exposed through driver interfaces, so you don't really have to go master all things vision to be able to create something compelling. So that's kind of all coming together. And I actually see a lot of very compelling applications over the next 10 years in that space because it's just the culmination of all these things coming together at the right time. What would I suggest to folks that are providing these technologies?
There's this Christmas wish list.
Sure, got it at. I think it's going to be the same wish list for a few years though. Part of, I've worked with technology providers and platform vendors and semiconductor vendors for several years now. And I often get asked the question, hey, we are designing our next part. Do you think it should do 1080p HD or 3 megapixel HD? Do you think 30 frames per second matters more or 60 frames per second? Should it do 12 bits per pixel or more? These are hard to answer. It really depends on the application. And in fact, it's not a spec game if you're trying to do a vision product. You're rarely going to choose a processor based on its specs and chops because there's a certain baseline you're going to look for. But then at the end of the day, you're going to look for what's it going to take for me to get from A to B, and B meaning my customer's need. And most processors today, I think, provide a pretty reasonable baseline. And I would actually rank accelerated vision blocks somewhat lower on the priority list. And I would rank just a mature and available software stack and drivers. So it's more important to be able to pull that first prototype together in a matter of weeks without spending a lot of resources on it, and then refine it and take it to product. And whether you're a startup or you're a group within a larger organization, it's just the whole rapid prototyping idea, the whole agile method that I think gets a lot more mind share, right? You know, you want to show some results early, get mind share, get buy-in, test drive it with customers. And one of the things I have to stress is, you know, from a product company's perspective, you can never test a vision product out, you know, enough. You got to keep doing it under all sorts of environments and conditions.
Last question.
Sure.
We've covered a lot of ground today. Are there any key points, any key messages that we haven't touched on that you'd like to leave with the audience?
Well, I'm really excited. I mean, this is a great time to be in embedded vision. So I think it's up to us to make it happen and make this next decade the decade of embedded computer vision. I mean, you know, people did the internet's done, smartphones are done, and now it's the time for embedded vision.
Good. I'd like to hear that. Well, thank you very much for spending time with the Embedded Vision today. And thanks to all of you for tuning in and watching this video. Please make sure you check out all the other great content on the Embedded Vision Alliance website, whether that be other videos, interviews like this one, or tutorials, or technical articles. And please come back and revisit the website regularly because we'll be putting up new content on an ongoing basis. Thanks.